hopefully on the previous page you viewed that video and then wrote down anything you thought might be important or anything you might forget. But in summary, the probability that an event will occur is a number between and including 0 and 1. So they say that here. 0, the probability of 0 means it can't happen. An event will not happen. Or cannot happen, I guess. It's not possible. And then a probability of 1 means that the event we're interested in is certain. It will definitely happen no matter what. But usually events are somewhere in between 0 and 1. It's not that they cannot happen at all, and it's not that they're certain to happen. It's somewhere in the middle, right? So probability, for that reason, probability is always between 0 and 1. So now let's take a closer look at how we calculate probabilities. A little bit more of what we've been looking at before. So here, you may have had some experience with probability using coins, cards, and dice. Usually if you've seen some kind of probability in previous math classes, that's what you'll talk about. So for example, what's the probability that when you flip a coin you get heads instead of tails? Or what's the probability that when you roll a die you get a 4 as opposed to 1, 2, 3, 5, 6? We can answer these types of probability questions without collecting data. In situations where outcomes are equally likely, we can use mathematics to calculate the probability instead of collecting data. For example, what is the probability of getting heads when you toss a fair coin? I guess a fair coin means it's not weighted on one side. If it's more heavier on one side than the other, it's more likely to fall on one side than the other. We're assuming that this coin is weighted equally on both sides so that you have exactly 1 out of 2 chance or 50% chance of getting either side. There are 2 equally likely outcomes, heads or tails. So, to use a little equation or more of a math feel here, the probability of heads, remember that's how we used our terminology we write it in math, P parentheses, whatever the event, however you want to describe the event. So probability parentheses heads equals 1 out of 2 or 1/2. The probability of rolling a 4 when you toss a die, and you can write that as P parentheses 4, is 1/6, and that's because there's only one way to get a 4, and there are 6 possible outcomes, and they're all equally likely. These are examples of theoretical probability. That means I didn't have to do any experiments. I didn't have to actually roll a die or flip a coin to know the probability. There was no experiment or data collection necessary. For most things in life, that's not possible, right? It's usually these very simple things, like cards. If you play a game of cards with a standard deck of cards, you can calculate probabilities. Coins, die, that kind of thing, but the more interesting statistical analyses, is that the plural? I don't know, happen with things where there's no empirical probability. There's no theoretical probability. But what if the coin is not a fair coin? Well, if the tail side of the coin is lighter, then a coin toss is more likely to turn up as a tail. The probability of tails will be greater than 1/2, but we don't really know the probability. It's just something greater than 1/2 because the coin is weighted. Or what if we are tossing a bottle cap? Is the probability that it lands on the right side up 1 out of 2? Who knows? Probably not, because it's kind of weighted on one side or the other. We don't really know. In these situations, we may not be able to determine a theoretical probability, meaning I might have to actually keep tossing the coin, the weighted coin, or the bottle cap over and over and over and over and get a good feel for what the probability is. Instead, we collect data and estimate the probability based on how often the outcomes occurred in the data. This estimate is called empirical probability. So that's the difference. Let's see, we said theoretical probability, you calculate that, So for one thing, theoretical probability, it must be calculated without experiments, kind of like we mentioned before. The other thing is, theoretical probability is exact. So we make sure that, this is exact. We're not talking about weighted coins, either side is equally likely. So theoretical probabilities are the only ones that are exact answers. Other ones are estimates, and I think we even mentioned that over here. Situations where we may not be able to determine the theoretical probability, instead we collect data. Estimate. So notice down here they use the word estimate. When we're talking about empirical probability, which will be calculated with experiments, you will have to use some kind of experiment or statistical data to calculate the probability. But also the other thing is the probabilities are not exact. They're going to be estimates. They definitely use that word here, estimate, for a reason. Only only theoretical probability can be exact. We'll never have exact probabilities because our population is too big and our sample size is too small. If our sample size is the entire population, then the probability will be exact. But if we're only taking smaller samples, smaller than the population, it will never have exact probability. We've already been using the empirical probabilities. For example, we use a two-way table to estimate the risk of a fatality when not wearing a seatbelt. In that example, we used data about car accidents to estimate a probability of a fatal outcome.